This video is about cost effectiveness, or minimizing the cost of abatement across firms. So we're going to begin with marginal abatement cost curves for two firms. I'm calling them Firm 1 and Firm 2. So these marginal abatement cost curves have shapes that we've introduced in previous videos, and I've mapped them out separately for each firm. Firm 1 is on the left and Firm 2 is on the right. And you may recall emissions increase along the x-axis, and cleanup operates in the opposite direction. So cleanup increases as we reduce emissions. To begin this example, we're going to assume that there's no regulation, and that means that each firm pollutes where the marginal abatement cost equals 0. That is, there's no cleanup, and here we're at a total of 12 units of pollution. So this is because Firm 1 is going to produce 6 units of emissions. That is where the marginal abatement cost crosses that x-axis, and Firm 2 is also going to emit 6 units of pollution. And what we want to figure out is what is the cheapest way to clean up 6 units of pollution between the two of them. The main point of this exercise is going to be that I'll show you that the total cost of cleanup for all firms in the market are lowest when the marginal abatement costs are equated across firms. So you ready? This is a good one. We're going to begin with option number 1. That is, we will use a standard, and we're going to say that each firm has to clean up the same amount, 3 units each. So we're going to be cleaning up a total of 6 units. Firm 1 has to clean up 3, and Firm 2 has to clean up 3. So we'll begin with Firm 1. Firm 1 is going to go from 6 units of pollution to 3 units of pollution. And you may remember from previous videos what that means is that the total cost of cleanup is going to be that area underneath the marginal abatement cost curve. So it's the additional cost of cleaning up each micro unit of pollution. We add up all those marginal abatement costs, and we get the total abatement cost, or the area underneath that curve. So it's a triangle, and the area of that triangle is 1/2 the base, which is 3, times the height, which is 30. We get a total of 45. Firm 2 will do the same, reduce their pollution from 6 to 3, and that area of that triangle would be equal to 1/2 of that base of 3 times 15 would be 22.5. So let's summarize those costs. The total abatement cost for firm number 1 will be 45. For Firm 2, it's 22.5, and in total, we have a sum of 67.5. Now, after each one of these options, what I'll also be doing is comparing the marginal abatement cost of the last unit cleaned up. For Firm 1, that's 30, and notice here for Firm 2, it's 15. So if you compare those two numbers, 30 and 15 are not equal, and you may remember from the beginning of this video, I noted that the cheapest way to clean up any certain target level of pollution, here it's 6 units. So the cheapest way of cleaning up 6 units of pollution is going to occur where the marginal abatement costs are equated across the firms. They're not equated here, so we can expect that we can find a total abatement cost combination that's going to be lower than 67.5. So let's try some other different combinations of cleaning up 6 units. Option 2 could be that Firm 1 cleans up 6 units, all 6 units, and Firm 2 cleans up none. If that's the case, Firm number 1 will go from 6 units to 0, and the total abatement cost would be that full area underneath the curve. The base of this triangle is 6, the height is 60, we get a total of 180. So if we summarize these numbers, for Firm 1, the total abatement cost would be 180, for Firm 2 is 0, and the total would be 180, which is much higher than that 67.5 that we started with. And if we take a look at the marginal abatement cost of that last unit cleaned up, for Firm 1 we see that they're 60, for Firm 2 they're 0, and they are not equal. So let's try another option. In option number 3, we say that Firm 2 is going to clean up all 6 units. Now it might work out that this turns out to be cheaper, or you might think that there's a possibility that it's cheaper in this case, because if you take a look, the scales on the two curves are the same, and because they're the same, it's pretty obvious or clear that the marginal abatement costs for Firm 2 are much lower. So it's cheaper for this firm to clean up each unit of pollution. So if firm number 2 goes from 6 to 0 units, we get that full area and a total abatement cost of 90. So if we summarize those numbers, the total abatement cost for firm 1 is 0, 2 is 90, and it's a total of 90, which is again higher than that first one, 67.5. And if we take a look at the marginal abatement cost of the last unit cleaned up, for firm 1 we have 0, firm 2 it's 30, and again these are not equal. So let's take a look at option number 4. In this case, firm 1 cleans up 2 units and firm 2 cleans up 4, again for a total of 6. So firm 1 in this case goes from 6 to 4, and that means we have a total abatement cost of equal to 20. Again, the base on this triangle is 2, the height is 20, so we get a total of 20. And for firm 2, we go from 6 to 2, so firm 2 is cleaning up more, and the area of that triangle is equal to 40. So if we sum up those numbers, for firm 1, we have a total of 20, firm 2, 40, and a sum of 60. So that number is lower than the first option that we started with. Let's take a look at the marginal abatement cost now. The marginal abatement cost of the last unit cleaned up for firm 1 is 20, and for firm 2 is 20. So those marginal abatement costs are equal, which means that this is the lowest cost combination of cleanup for these two firms. So you could go through and look at different combinations. That means that if you were to take a look at the combination where firm 1 cleans up 5 and firm 2, 1, 1 and 5, or even portions of it, 4.5 and 1.5, you're going to find that any other combination of cleanup that gives you 6 units is going to be higher than this 60. So the question might be, where did these cost savings come from? So if you take a look, what you see is that firm 2 is doing more of the cleanup, and that's we're getting cost savings here because firm 2 has the lower cost of cleanup. And firm 1 also does cleanup, but they're going to be doing cleanup in the lower cost part of the marginal abatement cost curve. That is those first units, which are the cheaper units to clean up. So the cost savings comes from a combination of having the firms that have the lower cleanup cost doing more of the cleanup, and the firms that have the higher cleanup only cleaning up the units that are relatively cheap to clean up. Okay, so let's summarize what we just went over. Option number 1, we had firm 1 clean up 3, firm 2 clean up 3, for a total of 6 units cleaned up. And in that case, the total abatement costs for firm 1 were 45, firm 2, 22.5, for a total of 67.5. And the marginal abatement costs for firm 1 were 30, firm 2 were 15, and these were not equal. And option number 1, we had firm 1 clean up all 6, firm 2 did not clean up any, for a total of 6 units cleaned up. The total abatement cost for firm number 1 were 180, firm 2, 0, for a total of 180. The marginal abatement cost of that last unit cleaned up for firm 1 were 60, firm 2 were 0, and these were not equal. Option number 3 meant that firm 1 wasn't cleaning up anything, but firm 2 cleaned up everything, again for a total of 6. Firm 1 had no total abatement costs, firm 2 had 90, for a total of 90. Firm 1's marginal abatement cost of the last unit cleaned up is 0. For firm 2, it was 30, and again, these were not equal. And finally, for option 4, firm 1 cleaned up 2 units, firm 2, 4, for a total of 6. The total abatement costs for firm 1 were 20, for firm 2 were 40, for a total of 60. And the marginal abatement cost of that last unit cleaned up for firm 1 were 20, and firm 2 were 20. These were equal. So what this exercise shows us is that we can clean up the same amount of pollution at a lower cost when the marginal abatement costs are equated across firms. So, why does this matter? Why should we care about this? Well, what this tells us is that standards are not a cost-effective policy instrument. Standards were never equalize the marginal abatement costs for all firms. This means that society often spends more on environmental policy than is necessary, and that's because most often standards are the go-to environmental policy. On the other hand, economic instruments, that is taxes, permits, and subsidies, are cost-effective. So you may remember from previous videos, when firms, or in our case landholders, are given a choice to either pay a tax, buy a permit, or receive a subsidy, they'll all make the decision to reduce emissions until the marginal abatement cost is equal to that price of pollution. That means when economic instruments are used, marginal abatement costs are always set equal to that price of pollution. But this does not mean that economic incentives are always a best policy option. They do require strong government institutions to run and are often politically infeasible. That's why we'll be talking more about policy mixes in this class than the use of one particular policy.